You said you do some light editing afterwards anyway, right? So we can give it a moment for folks to wander in. And I see folks coming in, so great to be able to share what we're doing here. And let's give a few more people a chance to grab a cup of coffee. My commemorative Budapest mug, which is getting blurred out. Everything good on your side, John?
Good to go.
Finger, mouse at the ready. Yep.
Oh yeah.
All right. Just give it to the 2-minute mark and someone else join us. And let's see, move the window so I've got the important ones here. All right, let's give it a go. Good afternoon Eastern time. Good morning for those on the West Coast. I'm Carl Bangert. I'm here with Flex Structures and part of our Sandalwood webinar series about IPS cable simulation and various add-on modules and topics that kind of extend what our customers have been doing with IPS cable simulation. We're here today, as I mentioned, using the Zoom platform set up to us graciously by our technical partners at Sandalwood Engineering and Ergonomics. Sandalwood has a team of 130 plus engineers in North America, Canada, and the US and Mexico, supporting systems engineering, digital engineering, and injury prevention and ergonomics and various OEMs and tiered suppliers. And we're happy that working together with Flex Structures, our offices throughout the world are based in Germany. If email has been kind of slow getting to you this morning, this week is the week that we're moving offices in Kaiserslautern, pretty much down the street, but our servers are being moved right now, and hopefully the rest of Flex Structures will be online here by later this afternoon. So the Germans are working through the day on this. But we're the sales and distribution and development arm for IPS cable simulation. Here today is the other face in the screen is John Lukowitz, who will be performing the demonstration of IPS cable simulation. He leads the digital engineering technical team. Myself, I'm Carl Bangert, General Manager of Flex Structures North America, here to support you in your simulation endeavors. Our topic centers around the uses of and the increased use of virtual validation, as evidenced by companies such as early adopters like BMW, Volkswagen, and Mercedes that have been able to move away from costly and time-consuming hardware prototypes in their development and test labs to clearing out the space because of virtual validation, being able to use IPS cable simulation and the various IPS tools to get a handle on routing of cables, flexibles, and hydraulic hoses months to years before start of production. So, more case studies like this will be presented at our IPS Cable Simulation Users Conference in September. in Kaiserslautern, Germany. If you can make it over there, we would love to have you and be able to see the latest work that we and our clients, your colleagues, are doing in this space. So our focus on today's presentation is, as we have the getting a handle on the messiness that is wire harnesses and cable routing in our increasingly electrified vehicles. And our topic today really is the importance of how does this bundle of spaghetti turn into something nice and neat in the vehicle, is through the help of another set of tier suppliers who provide connectors and clips to these electrified systems, and a bit of an insight into how these are managed in IPS cable simulation. So as we look through this in the coming weeks too, we're focusing right now, the last few weeks have been on IPS cable simulation. We'll move from product development side also to virtual validation of manufacturing and service by things such as the IPS assembly path planner and IMA, our intelligently moving mannequin, to take a look at how the installation and service of these harnesses and connectors and clips will work in a simulation environment. Today we're looking at the clips, and I'm turning it over now to you, John, to show us what for in IPS cable simulation.
Thanks, Carl.
And real quick, if you do have any questions, please put them into the Q&A. I'll be monitoring that and sign off for now.
Absolutely. Thank you, Carl. So as we know, connectors and clips are certainly an important aspect of many flexible designs. So understanding where and how your cables and hoses are fixed and the behavior of those connecting components is really critical to reaching an optimized design. So using the IPS tool, users can define the specific behavior of connectors and clips, things including the number of fixation points, the support range of the clip, how much of the cable is it actually supporting, as well as kinematic behavior. And then once we define those things, those connectors and clips can be added to a user's IPS clip database to be reused over and over again in any studies that you may be performing. So today we're going to go through the setup of a basic clip. You can see one here. And then we'll show how this clip can be inserted into an active study to alleviate an issue with a design condition. So to begin, I'll just go to a blank session of IPS. And in order to set up a clip in the software, the first thing we need to do is have some geometry. So I've just got some JT data here of a clip, but keep in mind you could use any IPS compatible format. There are many. And I'll just import this into the software here. All right, so we can see our clip geometry. And now in order to define this as a clip in IPS, I'm just going to go to the flexible dropdown and select the cable clip browser. This will open up the small database of connectors and clips that come with the IPS software. You can see their product IDs, names, types, and descriptions. And also, if we select any of them, we can see a little preview of what that particular clip or connector actually looks like. So if I want to add a clip to my database, I just need to select Create New here. And that's going to open up for me my clip wizard. So the software really walks us through what we need to do to create any kind of clip or connector that we would need. So step one is to select some geometries that we'd like to use. We can import them at this point as well, but I can just drag and drop these two geometries for my base. And then the upper portion here is actually going to rotate about this central axis of the clip. So we will have a kinematic on this one. Once my geometries are selected, I can just hit next. And now it's asking me to position the base frame. So what is the base frame? It's the frame that aligns the clip to the scene when we insert it into a design in IPS. So for this one, it's just going to be the center of this base here. So I'm just going to select my base frame, and I can use any of the positioning or alignment tools that are available in IPS to position my base frame. So I'm just going to align it to the center of this base. That looks good to me. Once I've got my base frame defined, I can just hit next, and the clip wizard will continue taking me through this dialog to set up the clip. So now we need to create links. So links are essentially rigid bodies that make up our clip. Now, in the case of this clip, because we have a kinematic, we want this upper portion to be able to rotate. We're going to need two links, a link for the base and a link for the upper portion that rotates. You could certainly just have one if you just had a static clip or connector that didn't have any kind of kinematic defined. So I'm just going to create two links. And by default, the software has already associated those geometries with those links. And now I just need to create the hierarchy for how I want this thing to move. So I want this upper portion to rotate based on the position of this base. So I'll just drag and drop to link these together in this clip staging area in the scene tree. And then the last thing I need to do here is if I want it to rotate about this central axis, I need to make sure that I relocate that central axis to the center line of this little cylinder here. So to do that, I'm just going to turn off some of this geometry. And once again, I'll just use my alignment tool to align this to a circle. Hit OK. And then we can continue through the clip wizard. So selecting next, it's now asking us to define the joint properties for this specific clip. So once again, we have two joints. One is the base, and that will not have any kind of kinematic associated with it, right? It's just going to be fixed to whatever our product is. And then the next joint is this upper portion. So if I'd like to define a kinematic for this, I can simply right-click and go to Constraints here. And you'll see by default, the type is fixed. So by default, all of our joints, begin with no kinematic defined. But we do have the option to define prismatic or revolute joints to build in some translation or rotation into the model. And however complex the clip may be, we can string together these joints to create any kind of motion that could be necessary. So for this case, I'm going to select a revolute joint. I want it to rotate. And then I want to define the axis of rotation as the Z-axis, which is this blue line here. We have a couple more options. We can define a range of motion, right? So if this particular clip could only rotate within a certain degrees of freedom, we can define that here. We could also define a nominal value, basically a home position for this clip. But in this case, I'll just give it free range of motion. The other option we have is to define some stiffness value. So for a revolute joint, that would be in Newton meters per degree. For a prismatic joint, it translates, it'd be in newtons per meter. And we can define some resistance value. How difficult is it for this clip to rotate? In the interest of simplicity, I'm just going to leave the stiffness value as 0, but just be aware that you could define it if you'd like. And then at this point, I can select this button here to test my mechanism and make sure that everything looks like it's functioning properly. So I can see this portion of my clip that I want to rotate does in fact rotate. And I can move on in the clip wizard. Next, we need to define a director frame. So essentially a mount frame. Where is our cable going to attach to this clip and how is it going to attach? So to do so, I want to add my mount frame to this upper portion of the clip. So I'll just select link 1 and add director frame. And you can see that the software has already put it in this clip staging area for me as a child of link 1. By default, it's going to come in at the origin. So once again, I'll need to use my alignment tool to align it to whatever position on the clip is appropriate. So for us, that's going to be the center of this circle here. So I'll just use my alignment tool to pick a circle. Okay. And then I'm always going to want my Z-axis going through the clip. So that looks good to me. And then I've also got some other options here. So if I right-click on that frame, you can see my mount constraints. So I can define various types of attachment between the cable and this clip. Fixed frame being totally fixed. Fixed tangent meaning that the cable would be allowed to rotate along its axis in this clip. And pivot meaning that it would be able to rotate in every direction about this mount frame. And then we also have an option for longitudinal clamping. So if I want the cable to be fixed along its length, in other words, unable to slide through this clip, I can leave this longitudinal clamping box fixed. So I will leave that. And then lastly, I need to define a support range for this cable, or for this clip rather. The support range is essentially just how much of a cable is going to be supported by this particular clip. So we can see this preview and an arrow showing the direction that it's going to be going in. And I can define this value. Just a moment. For some reason, it's not letting me change the range here. Yeah. So I can define how much of a cable I would like it to support. And in this case, I can just kind of mess with these arrows and find that this cable, based on the preview, is going to support 10 millimeters of any cable that would be going through the clip. And then our last option here is for an offset bundle. And that essentially means that if we select this box, the clip is going to mount the cable based on its specific diameter. So we do run into situations where clips or connectors can accept a variety of different sizes of cables or hoses, and that's going to move the cable relative to its diameter. In this case, this clip is really designed to only accept one diameter of cable, so we will leave the offset bundle unchecked. Selecting next in my clip wizard. This is the last step. I just need to define a product ID. So maybe some part number, something like that, a description. So whatever we would like to define, maybe I'd call it a Revolute clip, a name. So for instance, wheel speed sensor clip, and then a type. So if we'd like to put any details like, Revolute, fixed frame, anything that we'd like to include that will then be available in the clip database after we've saved this. At this point, I can test my mechanism again if I'd like, just to make sure everything's working properly. And then we also have a button here to validate the clip. So if I check with the validate button that the definition is valid, that's going to mean that we've set up everything correctly and we're okay to go ahead and save this to our library. So I will select finish. And then we can see that clip is now available in the database. And then lastly, I'll just need to save my database so that I can use this in any other IPS studies that I'd like to. So I'll select my clip database here, select save, just to overwrite that. Now, what does this mean in practical application? So we were looking at an example with this wheel speed sensor. And as we can see in this design, there is no clip constraining the wheel speed sensor cable. So I'll just play through my motion here quickly. We can see that there's some really tight clearances. There's some crash conditions between that wheel speed sensor cable and the spindle. It looks like a clip would certainly benefit us in this scenario. So now that I have a clip defined, I can very easily insert one into my study. And to do that, all I need to do is have a node, basically an attachment point. Where do I want to insert the clip? So I've pre-placed one here. And then for any node to insert a clip from our database, I'll just need to right click, go to insert clip, and then we'll see all of our options here. So if I'd like to check out my database, I can just hit the three dots on the right. It will show me every clip that's available to me in the database with those product IDs, names, types, descriptions, as well as a little visual preview. So I'll just select my wheel speed sensor clip here and select insert and apply. We'll see that come into the scene. And now if I'd like to attach my wheel speed sensor cable, lastly, I just need to add an additional grip on this cable so I can attach it into this particular connector or clip. So I will just add a grip. I'll just pick kind of an approximate location along the cable that I think looks good for this application. Keep in mind, we can edit this very easily later. And then lastly, I'll just need to drag and drop that grip onto the mount frame for my clip. It's going to show me a preview of how this cable will be attached. Notice that these two red preview arrows are going in the same direction, and I'll hit apply. And you can see that it's automatically constrained the cable within that clip. Because we have a revolute joint on this clip, it's automatically adjusted the position. And if I play through my motion once again, we can see that this clip is doing a good job of keeping that wheel speed sensor cable away from our spindle here. Obviously, we have all of the other functionality that we normally have with the IPS software to do analysis of the cables, create distance measures, motion volumes, tolerance envelopes, etc. But having the ability to insert these clips and very quickly and easily move them from study to study as needed is certainly very powerful. I did also want to just show a couple of more examples of clip applications in IPS. So I've got a couple of just very basic models here. With just on the left, we've got two cables that we'll want to connect together. And on the right, we've got a cable and a rigid body that actually came out of a trunk assembly we want to attach together. So once again, to use these clips, once they're defined in the database, all we need is a node, place that we want to insert the clip to. Once I have that node, I can just right-click and go to Insert Clip. And my database becomes available to me. So if I look in the database, I can see for this application, this clip ID 10 looks like a really great application here where we can connect these two cables together. So I'll just hit Insert and Apply, and we'll see it come into the scene. And then once again, to make these attachments, we just need to add some grip frames onto our cables. So I'll just create a couple of those approximately near where I want to attach them into the clip. And once again, keep in mind, you can very easily edit these locations later on. And now to make the attachment to the clip itself, I've just got to drag and drop these grips onto the mount frames under the clip. So grip 3 is going to go to mount frame 0. Once again, it gives me a nice preview of how it's going to attach in there. And I actually want these two arrows going in the same direction. So I'll just click the flip direction button to quickly correct that. And we can see that our cable is now constrained by the clip. And I will do the same thing for the other side. We can see the preview, hit apply. We've got a little bit of, we're missing some length here on this side. So if I want to edit my cable, I can very easily do that and shift some of this length on either side of that clip to give it a little better behavior. And now we can see the behavior of this kinematic clip in our study. So if I were to, for instance, take the end of the cable and move it, we can see how that connector is behaving in real time and connecting these two cables together. One last example I'd like to share, we can also certainly connect cables to rigid bodies. So this is actually an arm from a trunk assembly. And in this case, we would want a clip that would actually have a fir tree connector that would insert into this hole here. So once again, if I just select my node, insert clip, can go to my database and find a clip that seems suitable for this application. So this one has a fir tree connector and a nice long support range to hold that cable. I'll just hit insert and apply. And then one thing to note here is this is one of those clips that actually has an offset bundle, right? So this clip could accept many different sizes of cables, probably be fixed with something like a zip tie. And if I want to attach my cable to this clip, once again, I'll just find my grip in the center there, drag and drop it onto the mount frame. We'll see the preview of how it's going to attach. And once again, if I move the ends of this clip, we can see that behavior in real time. So these are just some basic applications of clips and connectors in IPS, how we can set them up and how we can continue to leverage them once established in any IPS studies that we may be performing.
Thank you, John. Really covers the breadth of different types that you can get and their their connectivity. How would you go about, let's say you've been working on getting clips put in, how would you go about sharing that with a colleague, let's say, right? Because the clips are in a shareable library.
Yes, absolutely. Yeah. So once you have this clip database established with any of the clips or connectors that you're interested in and they're defined, you could simply email it and they could link it into their IPS study. So if I just create a node here from scratch, so we can look at inserting a clip. Once again, I'll right click, insert clip. We can see here, there's an option for whatever database we would like to use. So we have a variety of databases we can access for different applications. You can add as many or as few as you'd like, and they are very easy to share and reuse. So it's not as if you have to set anything up special. These database files are quite small.
Great. And the other visualization tools, right? How would those work? How are those affected by the clips, right? Because now you've got a rigid connection, which might affect the bending radius in a clip connection, right?
Yeah, absolutely. So for instance, if I were to create a visualization here of the bending radius, you can see how it's changing based on the fixation on that clip. So again, the cable is going to behave as if it were fixed in whatever way that you've defined when you set up the clip.
Mm-hmm.
And then that, if we do happen to have a kinematic behavior, that's also going to have an effect. We can define them in a very realistic way to reach a very robust, realistic simulation.
Right, because in that one you'd put a revolute joint, is it in it, right? So it's rotating with the clip.
Yes. Yep. The motion is sort of small in this case, but it is moving slightly as we go through the motion of this spindle.
Terrific. Well, that question had come from our participants here, and looking for any other Q&A right now seems to be a bit quiet, and so it looks like a lot of good information was covered. Why don't, in the last minute that we have here, give us a preview of next week's webinar, John?
Yeah, absolutely. So next week, as Carl mentioned, we'll be covering the rigid body path planner, which is a tool for automatically planning collision-free installation paths. So that could be for a component in an assembly, could be for a piece of tooling. We've even had clients use it to figure out an equipment installation path into a facility. And then we'll also be pairing that with our IMA mannequin, which is our digital human model, to do some ergonomic analysis. So it should be really great. And then the following week on August 8th, we'll be hosting another webinar at Kettering University that will be covering some of the virtual reality capabilities of the tool and how that ties into our digital human model as well. And you would be more than welcome to join that one as well.
Terrific. Thanks a lot, John, and appreciate everybody's time for joining us today. Taking a half hour for a bit of a lunch and learn here. If you do have any questions about these capabilities, let us know. We'd certainly welcome a chance to do a virtual workshop, look at your application, and provide any guidance that we can as you work with IPS cable simulation. So thanks again, and have a great rest of your day.
Thanks, everyone.